Approximately 8 million years ago in the warm coastal waters of present-day Peru, a diminutive baleen whale named Pisco bellina swam blissfully, oblivious to the silent predator lurking just below. This little whale, about 3 to 4 meters in length and roughly the size of a beluga whale, filtered mouthfuls of plankton-rich water, unaware of the danger that awaited. The predator, much like the great white sharks of today, hunted whales from beneath or behind, relying on the element of surprise to strike. Pisco bellina, however, lacked the ability to echolocate, making it an easy target. The predator, identified later through a tooth left in the whale's body, was none other than Megalodon, the largest shark ever to have lived. Reaching up to 18 meters, Megalodon was almost 3/4 the size of a modern blue whale, and its teeth were as large as a human hand or bigger, with jaws wide enough to swallow a human whole. Megalodon roamed the world's oceans, from the Netherlands to New Zealand, and for over 10 million years it reigned as the ocean's apex predator, until 2.6 million years ago when it went extinct. The mystery of Megalodon's extinction is complex and multifaceted. While Hollywood may have led some to believe otherwise, the truth is that Megalodon vanished entirely from the fossil record, just as the Pliocene gave way to the Pleistocene. This phenomenon, known as a fossil gap, is not uncommon in the history of life on Earth. The disappearance of Megalodon has been a subject of fascination and debate among scientists for decades. Megalodon belonged to the diverse order of sharks known as lemniforms, which today includes Santa Evers, goblins, threshers, and the great white. When Megalodon was first described in 1835, scientists thought that its big, serrated, blade-like teeth looked so much like those of the great white that Megalodon was originally placed in the same family. However, today, based on features around the base of its massive teeth, most experts think that it was probably in a separate family, whose members are all now extinct and known as the megatooth sharks. The oldest and smallest of the group of megatooths that gave rise to Megalodon was a shark known as Otodus obliquus, which lived in the early Eocene, nearly 20 million years before Megalodon appeared on the scene. Some scientists believe that Megalodon belonged to the same genus, Otodus, while others assign it to another genus of extinct sharks called Carcharodontis. Regardless, Megalodon was the largest of all the megatooths, first showing up in the fossil record about 23 million years ago. The massive size of Megalodon was linked to the size of its prey, and both were shaped by forces much bigger than the shark itself. The uplift of mountains in North America and Asia caused by plate tectonics during the end of the Mesozoic era pumped massive amounts of nutrient-rich sediment into the oceans, increasing the productivity of ecosystems near the shore. As algae and plants grew, so did the preferred food group of Megalodon, marine mammals. Marine mammals like whales, dolphins, and seals all have high fat contents, making them a nutritious, high-calorie snack for any predator that could catch them. As marine mammals grew over time, so did the sharks. Over the course of about 20 million years, marine mammals and the line of megatooth sharks that led to Megalodon both doubled in size. The rapid growth of Megalodon was particularly noteworthy. Fossils of newborn Megalodon found in places like Panama show that they were about 2 to 3 meters long, half the size of a modern great white shark, and about 1.5 times as large as their ancestor Otodus obliquus. These massive baby sharks grew like weeds, reaching their maximum length at around 25 years old. This rapid growth, along with their massive size, probably helped Megalodon keep up in the ongoing size race with the marine mammals it hunted. However, 2.6 million years ago, Megalodon disappeared. The reasons for its extinction are still a subject of debate among scientists. Some believe that the onset of the ice ages, which began 2.6 million years ago, may have had a direct impact on Megalodon or its food source. The change in climate led to a restructuring of how and where whales lived, with more productive environments taking shape closer to the poles. As whales started to spend more time there and became more migratory, it is possible that Megalodon was unable to follow. Other scientists have suggested that Megalodon may have been outcompeted by newer, more nimble sharks like the great white. In the late Miocene, the earliest ancestor of the great white, Carcharodon hubs, appeared in the fossil record. This shark was a direct competitor with Megalodon, as proven by its tooth marks that have been found in fossils of the same whale species that we know Megalodon ate, namely Pisco bellina. Then, a few million years later, in the early Pliocene, the first fossils appear of the modern great white, Carcharodon carchareus. In addition to having to compete with newer, more nimble sharks like these, some of Megalodon's most important prey, namely whales, were on the decline. Toward the end of the Pliocene, the number of whales dramatically decreased, from about 60 whale species to about 40. Many of these species were filter feeders and fed on krill and other organisms, which in turn ate microscopic algae called diatoms. Starting around 3 million years ago, the oceans began to experience a serious drop in diatom diversity, which may have had a ripple effect on the food chain, leading to fewer krill, which in turn meant fewer whales. Regardless of the reasons for its extinction, the disappearance of Megalodon had a significant impact on the world's oceans. In the past couple million years, great white sharks and orcas have taken over the roles of apex predator, but these much smaller carnivores could not hunt the larger whales that Megalodon was likely able to eat. For instance, we know that modern great whites frequently eat dolphins that are half their size, so it is possible that an 18-meter Megalodon was eating whales that were as big as 9 meters, much too big for other predators to handle. The absence of Megalodon may have also had a ripple effect on the ecosystem. Without the giant shark to keep the population of larger whales in check, it is possible that the size of whales exploded. During the Pliocene, the waters grew colder and the new and improved productivity at the poles meant diatoms bounced back. This newly productive environment, along with the absence of large predators, meant that the whales were able to become twice as big as the biggest whales of the Pliocene. This is why the blue whale, the largest animal our planet has ever seen, appeared in the fossil record only recently, less than 2 million years ago. Without Megalodon, the ocean's food chain was forever altered, and the niche of supershark remains open to this day. It is possible that the great white shark could become the Megalodon of the future, and that giant sharks might patrol our oceans once again. Only time will tell. The extinction of Megalodon is a fascinating reminder of the delicate balance between species and the profound impact that one creature's disappearance can have on the entire ecosystem. It is also a testament to the ongoing process of evolution, as new species rise to take the place of those that have vanished. As we continue to explore our planet and uncover the secrets of its past, we will undoubtedly uncover more stories like that of Piscobalaena and Megalodon, each one shedding light on the complex and intricate web of life that exists beneath the waves. Moreover, the story of Megalodon serves as a reminder of the importance of conservation efforts. Today, many species are facing extinction due to human activities like habitat destruction, overfishing, and pollution. By understanding the role that these species play in their ecosystems, we can work to protect them and prevent further losses to biodiversity. The extinction of Megalodon is a cautionary tale of what can happen when we fail to appreciate the delicate balance of life on Earth. In addition to its ecological implications, the story of Megalodon also has cultural significance. For centuries, stories of giant sea creatures have captivated human imaginations, from the ancient Greek myth of Scylla and Charybdis to the more modern legend of the Loch Ness Monster. The discovery of Megalodon adds a layer of truth to these tales, demonstrating that there is indeed a rich and diverse world of marine life waiting to be explored. Furthermore, the story of Megalodon can inspire a sense of wonder and curiosity in young minds. By learning about this ancient shark and its role in the history of life on Earth, students can develop a deeper appreciation for the natural world and a desire to learn more about it. This in turn can lead to a greater commitment to conservation and a lifelong passion for science. In conclusion, the extinction of Megalodon is a complex and fascinating event that has left a lasting impact on our understanding of the history of life on Earth. Its disappearance serves as a cautionary tale of the delicate balance between species and the importance of conservation efforts. At the same time, the story of Megalodon is a testament to the ongoing process of evolution and a reminder of the rich and diverse world of marine life that continues to captivate human imaginations. As we continue to explore our planet and uncover its secrets, we can only hope to uncover more stories like that of Piscobalaena and Megalodon, each one shedding light on the complex and intricate web of life that exists beneath the waves.